Hello, it is Advent of Code 2023 and it is day 4 and I just finished the challenge. Awesome. Today I thought it wasn't that difficult. Definitely easier than yesterday, in my humble opinion. And so if you want to see me solve it, just keep watching. And if you want to see an explanation of my code, plus this last segment, I've kind of merged them all together. I've already done some research and then I'm giving you my review of my code as I explain the changes that I'm making, like my little refactor that I do. The point again, I want to learn and I want to help you see, like, hey, try to learn something every day and try to take a new thing out. And that's what I'm doing. I'm looking at other people's code and see, like, hey, what are they doing that I'm not doing and that I can improve in. And I think that is a really good way to go forward. So, first segment is the solve. Second segment is then altogether the review and like showing what somebody else has written. So I hope you enjoy this, and let's get on for day day 4. It's day 4. Slight delay because my copy code again doesn't work. I need to fix that at some point. I have my input right here, my main right here. Let's go. Example inputs. Get your puzzle input. Add that in here. Okay, example answer is 13. Cards. The cards are divided. Let's see. Borrow my boat. Scratch cards. Okay. A list of winning numbers, then a list of numbers you have. You organize information into a table, you puzzle input. Yes. So as I also have been able to figure out, you have to figure out which of the numbers you have appear in the list of the winning numbers. Yes. The first that makes the card worth 1 point, and each after makes the card double the points of the. Yep. In the above example, card 1 has 5 winning numbers. Okay. And 8 numbers you have. Of the numbers you have, 4 of them are winning numbers. 48, for example. Okay. That means it's worth 8 points. 1, 2, 4, and 8. Fair enough. That goes the same. Pile of scratch cards. Okay. So this should be actually pretty simple. It's again a line by line code. Scratch score. Boop, boop. So for each line, now the parsing obviously needs to be done correctly. So let's split each side by, well, let's say line dot strip. I don't want an let's do line dot split. And then I'm just taking everything on the right out. So I'm just gonna say this and that. Data. Now I want to say data dot split by this. And that should be winning and mine. Okay, so if I print winning dot split and mine dot split, I should get the right numbers for each of those. Perfect. Perfect, perfect, perfect. I need those as integers. And actually, I'm just gonna make this left one. I'm gonna make a set. No, I'm gonna make the right one a set. The left one I can keep a list. So winning dot map winning lambda x int x for winning. Then I want to make this a list. And that is my new winning. And then I want to say mine equals set map lambda x int x, and then mine. I don't need winning dot split. Didn't do that yet. So I can take that away and can take that away. Okay, now I have a set and I have a list, and all I have to do now is I go for W in winning, and then score equals good 0. Is there a better way to do that? I don't care right now. I can check that later. For W in winning, if W in mine, then score times equals 2. If score equals 0, score equals 1. Okay, and then at the very end, I'm going to say scratch score plus equals score. That should be the first part. That was easy. I like that. Boom. Okay, part 2. There's no such thing. Instead, sketching only causes you to win more sketch cards equal to the number of winning numbers you have. No. No. That is clever. Wow. 30 scratch cards. Total cards. I'm sorry, that is hilarious. That is such a clever twist. I know that they do twists every time, but this is hilarious. Okay, especially you win copies of the script below the winning card. Okay, below the winning card equal to the numbers of the matches. So if card 10 were to have 5 matching numbers, you would win 1 copy of each of cards. Copies of scratch cards are scored like normal scratch. Okay. Okay. Copies of scratch cards are scored like normal scratch cards. You have the same card number as the card they copied. Oh. So if you win a copy of card 10 and it has 5 matching numbers, we'll then win a copy of the same card that one. Oh. Okay. Do they stay in order? Wait, what? Your copy of card 2 also wins 1 copy of 3 and 4. Okay. Okay. I see. I see. So essentially, because 2 now exists twice, it has now, its values are now double. Okay. Okay. I think I start to get it. And I actually want to write down, I want to make some type of database of what's happening. Database is a strong word. So here my score is actually gonna be how often the others are gonna be needed. So scratch needs. I'm not 100% sure yet. Okay. And what I'm gonna say, or scratch values. And I can actually keep that as a list like this. I'm just gonna say scratch values.append my score. That way I'm getting a full value of the scratch values, right? 822100. And this is where it should have already be given me a clue. 822. Wait, why is it 8? Thought I was supposed to. Container. Oh, this is. Oops, sorry. This is actually. I don't want score. I want count. It's like 0. Count plus equals 1. And I could probably now calculate the score out of count. I don't care about this now. I will probably fix that later. And I want to actually add the count in there. 422. No, that's correct. Now, I have all the values. So what... Scratch values, scratch counts equals... So there is obvious... I have the strong feeling this is going to be the first one where I need to be a tiny bit more clever about optimization, because this can just explode really fast. It doesn't seem like it, but I have the feeling it'll explode really fast. So for each scratch count, I'm going to say scratch counts.append 1, because by default there's 1 card each. And then I will say for I C in enumerate, and then scratch values. I want to then say for in range C. Is this correct? For I C. So that's 0, 4. And then I want to go 4 down. So actually, I'm gonna say J. I plus J. Zero plus 1, because I always want to offset it by at least 1. So I'm adding 1 at 1, 2, 3, 4, then 2. This seems right. So I now want to say scratch counts of this is plus equals, and this is the amount, and that happens the amount of times that we have the value in our current. So scratch counts of I, yes, plus equals, so usually it's just 1, but if there's 2 already, then this will happen twice, and I only need to I add, and that's already an optimization. Instead of having to run through every single one, I keep track of how many there are and do them all at once. That is already making it faster, hopefully. I hope it's fast enough. And then I need to say scratch counts of I equals 0. Okay. Fair enough. That is the idea, that this happens. Now I need to count how often this happens. So Total cards. First of all, they are added here, 1 card each. And then I add, for every time I add more cards, plus equals scratch counts I. Huh! And that's it! Okay, that was way faster than yesterday. Let's see my leadership. And that is my best rank so far. I'm actually really pleased with it. Okay, so let's get through the code review of what exactly my code does. So, again, what is the question here for this task? The question here is we're getting a bunch of scratch cards, and those scratch cards have winning numbers on the left, then have a vertical line through it, and then we have our numbers that we took. And then we just want to see how many of those numbers that we chose are winning numbers. And that is actually really simple. And then we calculate the score out of this, starting with 1, 2, 4, 8, 16, and so on. Every time it doubles, every time we have a winning number. Now for part 2, these work very well together. For part 2, we don't care about the score, but we just care about the amount of matches. And what we do here, and I laughed out loud during the challenge because it's a clever twist. I always love the twists that they do, and this one came kind of unexpected. Is that if they want the first card has 5 matching numbers, that means the next 5 cards after it we clone essentially. So we have 2 2s, 2 3s, 2 4s, and so on. And then for each of those cards afterwards, I need to then again check how many do we have. So if we have 2 winning numbers and 2s, then we add like a 3 and a 4, but we add it twice now because we actually have 2 cards with the value 2. And that is it. This is here the mental note here is instead of processing every single card on their own, what you want to do is do each number as a batch, so that I don't think in this case that would make a big difference. It could. Advent of Code has the reputation to give you increasingly more difficult challenges where computing power is going to become an issue, where you then need to start cutting corners and try to make it work smoothly so that the challenges actually work. And this is one way that you should be starting to do this. Instead of doing every single car, try to think about a way to do them in batches. Okay, so how did I solve this? And I'm just showing you this solved solution, and I've also already looked at somebody else's afterwards, Oliver Nee, and gotten a time and inspiration. And I'm going to show you. So here I had a little issue with raising to the power. I'll show that in a second. And default dict is now I've seen that a while ago. I forgot now what default dict exactly did. So I'm now trying to remember what default dict does. A default dict is a dictionary, like an ordinary dictionary, except that usually in Python, when you try to access a key that doesn't exist, it gives you a key error. In default dict, it gives you a default value instead. Really clever, and it is helpful for tasks like this where you don't want to initialize a dictionary with all of the values initially. You just want to get going, and all of the values are going to be the same initially anyway, right? So that's now an improvement that I'm not going to make here, but I want to tuck into the back of my mind for future tasks is use default dictionaries. Use default dictionaries. That is going to help. That's my learning thing for today already. But how did I solve? How did I solve for this? First, sanitize the data, split the data, then go winning and mine. Sorry, I just checked for something. Yeah, the winning numbers and my numbers is split by this value, and apparently it's not necessary. I separated between a list for the winning numbers because I want to iterate through them, and a set for the mine because I just want instant access all of those values. I need to make sure that they're all numbers, and then I split them all, and then I have all the values in here. Now, for part 2, I want the count, and I can use that for part 1, so I've now rearranged it. Initially, I just wrote a for loop for W in winning, so for each value in the winning set, I want to check is W in mine, and if that is the case, then I increase the score. I double the score. If the score was 0, I set it to 1. And then in part 2, you just want the count. So you just add count plus equals 1. Then, as an improvement afterwards, what I wanted to do is I wanted to say score equals math floor to the power of count minus 1, because that is the math formula that you need to get out of count the score, because it's always times 2, right? Starting with 0, so it's minus 1. Except that for count equals 0, you actually get 0.5 as an answer. Because you're suddenly taking, I think, the square root, if I'm correct. Yeah, but you are getting suddenly 0.5 as an answer. That's why I said, oh, math floor. But this is unnecessary computing power for any other. So that is actually technically cleaner. I also, at first, completely forgot. I thought that was the power symbol, but it's not. It's the double star. So know your syntax as another tip. So all of this stuff is now simplified in these 3 lines. And this is one thing that I also just took now from Oliver Nee, another thing that I want to learn. And the way this works is for W in winning, so the same for loop that we did. And he did it different. He did it with counts, but I'm doing it different. So we're initializing the W value here with this for loop. And this left part is part of this for loop, and it keeps going in this for loop, which is clever. What I say is W in mine. Now this value is truthy, which means if W is in mine, we get true or 1. And if it's false, then we get false or 0. And that is very easy to sum. So I like this one-line way to do this, and I need to wrap my head around that I can do these things in Python, and I don't have a lot of experience with that yet, so that's why I'm writing this here now and try to write it out so that I can learn. But yeah, that's how you get count, and that's how you get your Scratch score, increasing your Scratch score. Now, for the second part is I have the values, and it seems like I don't actually need to create this dictionary, this array, this list, but I do it anyway. And here I also create the Scratch counts and append 1. This is where I could just do a default dictionary. And then I add total cards plus equals 1. This loop I could probably do, no, not probably, I can really do the same loop here. So that's why I don't need this. I could just do it all in one, but I'm just going to keep it for now. So I'm going through all of the Scratch values. And then I'm going ahead, whatever the value is that we counted. Like if there's 4 matches, we go ahead by 4. And each time, so we increase the Scratch count by the amount that our current number has. So if the second card has, like if we have 2 of the second card, and the value is 3, then we go 3 down. So the 3rd, 4th, and 5th card are now added twice. Because we have 2 cards instead of 1. So this is where we do it all at once. And then we say, hey, total cards is plus equals this, like however many we have. And then this last bit, I don't think I actually need. We just reset it. Yep, you don't need it. And it works all well. So, this is my solution. I hope it was helpful, and I see you for tomorrow's challenge. Auf Wiedersehen!